right, I'm going to show you how to run a notebook on the Pangeo Gallery. So we can search for Pangeo Gallery and head on over there. And if we look at the Pangeo Gallery, we see a number of different galleries that have been contributed by different folks that all get, but there's a sort of single web page here to access them all. And there's some cool climate stuff here. There's a nice Landsat tutorial if you're interested in remote sensing data. If you're interested in just getting started with Pangeo, there's some nice notebooks here. I'm going to drop down to this ESIP gallery that I maintain, click the logo, and we see a couple of different notebooks here. One is Hurricane Ike. I'll click on that. The notebooks are actually rendered here in the browser, but I'm not going to scroll down and give it away. Instead, I'm going to go over here and click this Launch Binder button, which allows us to actually run the notebook interactively on the cloud. So I click that guy. What's happening now is this Docker container is getting loaded onto the Amazon cloud that contains our software environment that will allow us, it has all the packages in place that will allow us to run this particular notebook. So it comes up here with a standard Jupyter Lab interface here. There's a little folder browser over here, a folder explorer or file explorer where we can go down and pick the notebook that we want to run. In this case, this Hurricane Ike case. And, we're in a regular notebook here, so we're in my local browser, but the code that I execute here by clicking Shift-Enter, for instance, you see this little star will turn to a 1, and it means I just executed this block of code. I executed that code on Amazon Cloud. And now I'm going to actually fire up my little cluster. I'm using something called Dask Gateway. You don't really have to worry about that, but it's running on a Kubernetes cluster. It's been set up for us with the same environment. And so we're asking for a new cluster here. And then we can tell it that we want to have a cluster that adapts. It's going to have 4 workers minimum, but it will go up to as many as 20. Or let's try 30. Okay, let's make it even a little faster. And so now we have this client that we have, and now everything that we do will be done automatically in parallel because we're using this Xarray package. So we've imported this package Xarray, and we're just going to open up this ZAR data set that's sitting in a cloud bucket. So this is just like, it's going to look just like a regular netcdf file. If I load this up, maybe actually I'll insert a new cell here just to show you that, this stuff, insert a new cell here to show you that this stuff is really, live. And if we can take a look at that data set, we can see the different data variables. So there's one called depth, which is has dimensions of node, and there's one called zeta, which is the one actually if we click on that, we can click over here and get a little bit more information about that, which tells us it's the water surface elevation above geoid. This looks very much like a netcdf file, right, that we've opened up from this ZAR format. So yeah, we can look at it this way too, just the same information, except we can see now that there's a chunk size of the original data shape is 720 time steps, and then almost a million, 9 million nodes. But we've chunked the data into these little 11 megabyte chunks that have only 10 time steps. So the files and the chunks in that data set have this sort of little chunking. And so this is what's going to happen. So when we actually process that, we'll be able to read all those little chunks with all those different processors we have. So if we take a look at the overall data set size, it's 53 gigabytes. And what we're going to do in this step is we're going to take the maximum over time of that data, okay? So all we have to do is say take the maximum over time, and this persist says, hey, do that computation and put the data that you're using to compute it on the worker nodes if you can, so we could use it for something else later. But before I do that, I'm actually just going to go up here, and I'm going to grab this dashboard URL here. Let's see here if I can grab that. Okay, I think I have to just go like this and copy it. And I'm going to paste that into this little Dask tab over here. So I'm going to paste that in there. If I hit enter there, these little guys turn to orange. And this is going to show me what's going on my Dask cluster. So nothing is really happening right now because we haven't told the cluster to do anything. I'm going to rearrange this, put my Dask stream here, this progress stream down here. Oh, there we go. All right, now I'm going to close this thing back down here because we give us a little more real estate. So let's see, where were we here? So we are down here where we're just about to execute this cell. When we execute it, we should see our Dask workers start working. And what they're going to be doing is, as I said, each individual worker, it starts off with the 4, but then quickly it realizes we have more work to do, so it scales up to more processors. It's actually doing that reading of the data from ZAR. Let's refresh here. And you can see these different workers kicking in, and they're all reading from ZAR and calculating the max on each little chunk. And then each chunk, like adjacent chunks, are being averaged together to get the, or combined together to get the maximum of that chunk in time. And so, you know, these guys are all working, you know, together with hardly any, if we saw white space in here, it'd mean that the workers aren't doing anything, but they're all working pretty much all the time. And with Dask, if one of these workers dropped out for some reason, another worker would just pick up and take that job and keep on going. So in a pretty short amount of time, in just a little bit over a minute here, so you can see the time ticking away on the bottom. So we're at 1 minute and 6 seconds, and we're done. So we've got the result, and if we just, I'm going to execute the rest of these cells just to show you the let's take a look at the result. And so let's see, actually, let's close these guys down because we don't really need them anymore. Get a little more real estate for our plots. So what we're doing is we're using this whole of views to take a look at that maximum sea level, and we can go in here. We don't really see anything, we see the whole East Coast, but what we're really interested in is down here, right? And all we've done is we've said to rasterize that result and to give us back the data on a 600 by 400 pixel view here. So the cool thing about these tools is because we've said rasterize, it's basically on the back end, it's delivering to us the graphics at the screen resolution. But we have these little zoom tools here. We can zoom in, and now this is going to re-render the resolution of the grid. And you can see there that it's just, I'm going to look down here just to show you that we can just keep on going to the full model resolution here. So that's pretty, it's really powerful. We didn't even have a way of representing these tools before this. So this kind of model output. And here is just an extraction at a particular time spot, and you can hover over and see exactly, at this particular spot when the maximum water level occurred. So these are pretty powerful graphics tools as well. All right, that's it. You should be able to run any of the other demos this way as well.